All right, we're up and recording now. Let's see, on the list we got here, we need to go over your index. You've got your code book with you?
Yes, sir.
All right, and then show you how to do the show window calculation,
Okay.
then voltage drop, and then voltage drop, then box fill and raceway fill.
Okay.
And then we will during one of our meetings you talked about, you saw something about asking how many, they gives you a square footage on a single family dwelling, and then it asks you how many 15 amp circuits are on there.
Yes, sir. Something like that.
Something like that. Okay. I've got a question. Was it a 2 or 3 story house, or do you remember?
I think it was a single family home.
Just a single family dwelling. Okay. All right, cool. Then we can go over that too. I've got some stuff on that to show you how to knock that one out real quick too.
Okay.
So let's start off in your code book.
Okay.
And this is gonna just be real easy. Get back there on the index.
The index. All right.
Yeah, go to the index. And then what you need to do is throughout the whole index, and you don't have to do it now, you can do it later, and it's going to help you speed up the process. But go in there and see that A that I have right here.
Okay. Yeah.
So that's the beginning of the index right there. And then on the next page, I've got a B, and then do I have it down low? And then what I do is I put it down low also. So it's just like the dictionary or something, you know, the last word of the index in the index on that page, write you a little letter. So when you're flipping through this index and looking for keywords, you can just look at the bottom and you don't have to start looking at all these little fonts and stuff, you know, right away. So dress up your code book that way also.
Okay.
And that's going to save you time. And there again, time is what is not on your side on this test. So that's one way of speeding up the process.
Instead of flipping, trying to get the right page.
Yep, exactly. And it's a real little simple thing that nobody ever does. And it's like, you guys got to get that in there just so it's quick. And then what you can do is, while we're back here, let's go to show windows, because that question that you've asked, or show windows, show up quite a bit on your tests. So when you get there, let me know.
Okay, and then the SE, let's find it. This is storage. Snow melting. On the SO, I just can't find it right now.
Okay, you're fine. You're fine. Snow melting, that means you got to go back a little bit.
Yeah, I'm back here now.
Okay.
Raceways. There it is.
All right, highlight it. show windows. Just highlight the word show windows. See the time it took you, like right now, to find it. Yeah, and then under show windows, under luminaires, and it says branch circuits. See that? Highlight that.
Okay.
Now, another thing, since we're back here, go back to snow melting. And then right above snow melting, there should be some snap switches.
Snap switches. Okay.
Highlight snap switches.
Got it.
And then highlight at the very bottom, right before snow melting, it says ratings. Should be ratings 404.14 or 14 or 14. Highlight that.
Yes, sir.
You may see that again on your test.
That's the other one that I couldn't think of. Snap switches.
Snap switches, not cord, not
No, it was cord cap, but it was snap switches as well.
Okay. Do you understand what snap switches are?
No, sir.
Snap switches are your just like your light switches.
Yeah, toggle switch.
Toggle switch, just something that has that blade that snaps back up and down, up and down. That's all it is.
Okay.
So when you get that question again on snap switches, it'll already be highlighted for you, and it'll ask you something about the rating. I forget how they word it, but so I just wanted you to get that highlighted because nobody knows the technical term for a toggle switch. It's a snap switch. While we're on that, molded case breakers. Did you see anything about molded case breakers?
Molded case breakers.
Mm-hmm.
And now I can't recall it.
Okay, if you do, it's just a breaker. That's all it is. They try to throw in molded case or something like that, and it's just a breaker. So don't let that throw you off. All right, let's go back to show windows and go to 220.14G.
Two 2041, right?
No, 14.
All 14. There it is.
G.
Other load, all occupancies.
Yes.
And then G is show windows.
Right. So highlight show windows again.
Okay.
And then highlight under show windows, there should be a 1 in the parentheses and a 2 in the parentheses. And under that 2, it should say at 200 volt amperes per linear foot. So highlight at 200. That's all you're going to really need out of that.
Okay.
So what you do is, do you remember your square footage or your linear feet on that question or something? You had like 19 or something?
Yeah, it's like 19 feet.
Okay. So what you do is you take that 200 and multiply it times 19. That'll be 3,800 VA. And what was it asking?
How many receptacles needed for a show window at 19 feet?
All right. Oh, never mind. So you're doing Did it say like something about likely and unlikely?
I honestly can't remember. I just
Okay.
know it after.
Okay. Let's go back. Let's go one more. I see what they're asking now. I thought you were trying to figure out your BA. You will see that probably, or it's very likely to see that they're wanting you to figure out the BA of a show window, and they'll give you
Okay.
a foot. So I thought that's where you were headed. So let's go to the next one instead. Right after show windows is fixed multi-outlet assemblies.
Mm-hmm.
Highlight that. And then under one, I'm sorry, highlight unlikely.
Under one.
Yeah, you see where it says one, where appliances are unlikely to be used
Okay.
simultaneously. So unlikely, that's all you have to highlight is unlikely. And then
Okay.
and where it says two, the parenthesis, well, the two that's in the parentheses, highlight
Mm-hmm.
likely.
Okay.
So that right there, did you see a multi-outlet assembly on your test? Something about a
I
multi.
I honestly can't remember. I just
Okay.
know that it was something about the show window, 19 feet, and how many receptacles would need for that window,
Okay.
and they give you like
Did
56, 32.
okay. Did they give you an amp rating on it or voltage amp rating? Were they 15 amp or 20 amp?
I think they're 15 amp.
15 amp. Okay. So what we've got to do is let's go back to the 3800 BA that we got off of our show windows.
Okay.
Because and then you divide that by 15. It didn't give you voltage.
It might have, but I don't really remember right now.
Okay, I think we're going to need voltage. And what you're going to have to do is work your Ohm's law backwards to find amperage on that. So
Okay,
you
just
got your
divide.
BA, and then let's see. Let me do
It might have
something.
been.
All right, so probably one of your answers was 32.
I believe so.
So take your 3800 BA.
Okay.
And we know it's a single phase receptacle, so that's 120 volts.
You
So you
just
take
divide it.
exactly, and you're going to come up with 31.66666. So you got to
And
round up to 32.
Okay. Yeah, so there was like 32, 19.
Yeah.
5, and then there's one like that was like 27. So
32
they're not gonna be 27. 27 in one
32 is
place.
your answer on that one.
Okay.
Because you just got to remember if they didn't even give you your voltage, that's just a regular receptacle, so you know your voltage is going to be 120. See how to get that?
Yes, sir.
All right.
In the pie.
Yeah. Yep. Exactly. So you just take your 200 VA per square foot or per linear foot, multiply it out, then divide it by 120 and go from there. But it'll probably be that same 19 linear feet again if you see it again.
Okay.
Now, what you do on the next one, the fixed multi-outlet assemblies, is they're going to give you likely and unlikely. And they're going to give you a footage on likely and on unlikely, you work them out the same, add them up, and then divide by 120.
Okay.
So
So the unlikely going to multiply by the 5 feet, right?
right, right,
And then likely 1 foot.
right. Exactly.
Okay.
Exactly. So just work that all out, just like we did the showroom or the
So,
show windows. Work it out, come up with your VA, and then um divide it by 120. And then
okay.
that's all you get. Now, unless they want to know what's the likely or unlikely, depending on the questioning, you'll be able to figure it out now that you know
Keyword.
this.
Yes, sir.
So cool. Show windows. We got that taken care of. It's real easy. It's just if you're not introduced to it and you're right in the middle of the test, you're like, what the fuck? What's show
Yeah.
windows? So we've got it marked in your index,
Yes,
and
sir.
now we've got it highlighted in 220. So you're good to go on that. And then likely and unlikely too. So
Okay.
all right, let's go to voltage drop. Let me see. Ding. And we'll go from there. Get this moved around. All right. So voltage drop is not a code requirement. In two parts of the code, it shows up in an informational note, but
Okay.
you got to remember informational notes are not enforceable. They're just kind of like suggestions.
Mm-hmm.
So it only, like I said, it only shows up twice and it's a suggestion. But if you are to get engineered plans or start building stuff according to the engineer, they always throw it back on us to do voltage drop to make sure everything's good. Or if you go in and you start um adding more outlets to a circuit, as a journeyman, you need to do the voltage drop on it just to make sure you don't have to upsize some wiring, some conductors, and go from there. But
Okay.
so voltage drop. Um, conductors conductors for branch circuits or feeders are defined in Article 100. Size to prevent a voltage drop exceeding 3% of the furthest outlet of power, heating, and lighting loads, and combinations of such loads, and where the maximum total voltage drop of both feeders and branch circuits to the furthest outlet does not exceed 5%, provided the reasonable efficiency of operation. That right there, that little statement right there may be a question on your test. And what they're going to be asking you is the 3% and the 5%.
Okay.
They'll be asking something about that. So keep that in mind on that. So here's your formula right down here for your voltage drop. VD, which is voltage drop, equals 2 times K times I times D.
Mm-hmm.
Okay. Divided by CM, which is your circle mills, which is your wire size. And we found those circle mills last time we met. It was in chapter 9,
Table 8.
table 8.
Mm-hmm.
So that's where we find that. So voltage drop is 2 times, and remember 2 means on single phase. To remember the 2, it's up and back. It's on your hot and then back to your neutral. Just kind of remember that. Up and back is your 2. Your
Okay.
K is, I'll show you where to find your K, and that's the type of wire you're using. it's either aluminum or copper, and your K will change depending on that. Times I, which is your current in your Ohm's law, and D equals distance.
Okay.
So it's 2 times the property of the conductor times the current times the distance divided by the circle mil of the wire that's that they give you in your question.
Okay.
So 2 kid over circle mil, or you may see it also with an L instead of distance, they say length. So it's 2 kil over the circle mil.
Okay.
Now, in other questions, what they do is they'll ask you the size of the wire, the circle mil of the wire, given your voltage drop. So you just substitute your CM and your VD. That's interchangeable right there, depending on the question. So you may want to, they may want you to find the voltage drop, or they may want to ask you what size wire you have, and then they'll give you your current, your distance, and your voltage drop that's occurring, and then what type of wire, aluminum or copper. So let's go to 3-phase. 3-phase is the same, except you replace the 2 with the square root of 3.
So the 1.7232.
Yes, correct. So when you're doing 3-phase, you have to just replace that 2 with that 1.732. It'll be the same scenario. They'll ask you for the voltage drop on a 3-phase system with aluminum wire. I don't know, 60 amps at 200 feet, and you're running 2 watt or whatever. So you plug all that stuff in and find the answer to your question.
Okay.
So right here, the K is for constant. And I don't know where they came up with constant. I'm sure it's some Greek word or something where they came up with. But for copper, your K is 12.9. And then for aluminum, it's 21.2.
Okay.
And if you go back to chapter 9, table 8, I'm hoping that's 705 in your book. Go back there. And we'll highlight it, the K value for you. Let's see, chapter 9, table 4, table
89.
What's that?
Page 689.
689 for you?
Mm-hmm.
Then must be 705 for me. It is. All right, so if you go down to on the left-hand side of table 8, if you go to 1,000, which is 1,000 kc mil, and then from 1,000, you're going to go all the way over to where it says 0.0129 on that.
Your OKFT.
Yes, exactly. Uncoated copper KFT, ohms per KFT.
Okay.
Highlight that.
Okay.
Now keep going over to aluminum, ohms per KFT on your 1,000 row. And
Mm-hmm.
it should be 0.0212.
Okay.
So if you look at those two numbers that you just highlighted, those are the same numbers that are right here. Except these are 1, not 1,000. So there again, we're moving our decimal places over. We're moving our decimal over 3 places to the right. So
Uh-huh.
in our book, it was 0.0129. We moved our decimal place over 3 places to the right and came up with 12.9.
Okay. Yeah, I see it. Huh?
So those two numbers are good numbers to have in your book, wherever
Mm-hmm.
you want to put them, wherever you remember voltage drop. So they're real quick reference. Also, after a while, you'll start memorizing them. You just know them offhand. If not, have them somewhere where you can reference back real quick, and then there it is.
Okay.
I bet you 9 times out of 10 you'll be using copper whenever they ask for voltage drop. So again, that K, the constant, is just these two numbers right here.
Depending if it's aluminum or copper.
Exactly. If it's aluminum, you'll put 21.2. If it's copper, you'll put 12.9. And they have to tell you, maybe they don't have to tell you. If they don't tell you it's aluminum, then it's copper.
Okay.
If that makes sense. We talked about that last time. So this right here, this little statement right here, they're going to ask you 3% and 5%.
Mm-hmm.
And then your K is this stuff right here that's highlighted in chapter 9, table 8.
Okay.
So here's a question for you. An 800 amp, or I'm sorry, an 80 ampere 240 volt single phase load is located 200 feet from the panel board and is supplied by a 3-ohm copper conductor with THHN, THWN insulation. What is the approximate voltage drop on this circuit? And they give you the K value right there.
K value.
Mm-hmm. So you know that this is a single phase load. So you're going to use 2 instead of 1.739 or whatever that. So it's 2 times kid.
2 times 12.9 times the
80.
I 80,
Times the distance.
which is 200 feet.
Divided by.
There to give a circuit was set to be VD permitted.
Yeah, you got it, but you got to divide it by the circle mills of that 3-ohm.
Oh yeah, since they gave you the wire, so
Yep.
3-ohm.
All right, it's number 3. It's number 3, not 3-ohm. And that'll be in chapter 9, table 8.
Okay, number 3. So it'll be 7.8.
Yep, exactly. Exactly.
Yeah, that makes a lot more understanding. I
Cool.
somewhat knew how to do it. But I didn't know what I knew the copper was, but like the kid, I didn't know what the KID stand for.
Gotcha. Exactly. And this is this is exactly why I do what I do right here. Because I can give you a whole bunch of papers and say, here, go figure out voltage drop, but a few little explanations and you got it picked up. All right, cool. Let's get you. Did I put any three-phase in here? Well, let's just do this one. What size? What I'm going to do is I'm going to flip through these screens so they get recorded, and then you can go back and rework these numbers,
Okay.
rework these problems, just so you got some practice and stuff. So on this one, you've got what size aluminum THW conductor is required to supply a 60 amp branch circuit 148 feet from a 240 volt single phase source. So they're asking you for CM and not voltage drop. And then right here it says apply the NEC recommended voltage drop for this branch circuit.
Mm-hmm.
So remember this right here, this note right here comes from that statement with 3% and 5%.
So aluminum's 3 and the copper's 5.
No. Aluminum will always be 21 point whatever it is, 21.9, 21.7, and copper will always be the 12.
Oh, okay. So that one that we wrote.
That will never
Copper.
change. That will never change. When you see aluminum, you're thinking 21. If you see copper, you think 12.
Oh, okay.
So what they're asking for is they're asking for your volt, your remember how it has 3% is
Mm-hmm.
your recommended voltage drop in a branch circuit, not your feeder circuits.
Mm-hmm.
And then you have 240 volts. So you want to see what 3% of 240 volts is. So you go 240 times 0.03, and that equals 1.2 volts. So 1.2 volts is your maximum recommended voltage drop for this circuit.
7.2 volts.
Yes. Because that's 3% of 240 volts.
So you have to find that right there first.
Right. Right. So first off, you got to know it for a branch circuit, because it asks you right up here for a branch circuit. So your branch circuit, you only get 3% voltage drop, and the branch circuit is 240 volts. So you got to find 3% of the 240 volts. Because that's your maximum voltage drop of 240 volts.
So it equals 30,093.
I got something different. 52,593. Oh, wait, let me see. Let's see. 2 times 21.2 times 60 times 148 equals. What'd you get? What'd you get when you multiplied all this stuff together up here?
216 and 672.
So did you take 2 times 21.2
Yes, sir.
times 60
Yes, sir.
times 148?
Oh, you know what? I might have done 12. My bad.
Okay. All right.
Uh,
Yeah, be
yeah.
careful. Be careful because where you're
307.
headed, they're going to have that answer for you.
Just so you can, like, all right, I got it right. Click it.
Exactly. You're like, oh, there it is, bam. And what they know is you put copper in instead of aluminum.
So it equals 52,293.
I got 52,593. So that's close enough. Cool. Now, so that's not your answer yet.
Okay.
Now you have to go back in the back of the chapter 9, table 8, under aluminum, and take that circle mill and see what size, standard size aluminum we use.
Aluminum.
Okay.
I was looking in the wrong spot, but I found it now.
I
It'll
think
be number 3.
Number 3, 52. Correct. Now remember, when they're asking you for size,
Mm-hmm.
it does not matter, because I've seen if you caught it or not, but if it threw you off, is aluminum, copper, it doesn't matter. Size is size.
Mm-hmm. Yeah, at
So
first when you said over to aluminum, I was like, that
yeah,
don't look right.
exactly.
So I get back to
Because
the circle.
you've already taken care of that aluminum right there when you put that 21.2 in. You
Mm-hmm.
took care of that right there. So now you're just looking for size. So you just go down on the column here and just work your way down and find wherever this fits in. So you got it.
Yeah, I'll do some practice once.
You bet. You bet. Let me
Now it's your single phase, right?
yeah, that's for single phase. What I'm just going to do is I'm putting these up on the screen for you so you can practice them.
Okay.
Let me go back. So when you
Go back, I can
yeah,
practice it.
exactly. And then here again, you can work your numbers different. You can change your numbers, you can do whatever you need to do just to practice on that.
Okay.
So change your numbers around, change your lengths around, change your current around, and then you'll get it. You'll just work it 2 kid or 1.73 kid, whatever, divided by circle mill or VD, and then go from there. So that's pretty much voltage drop. Can't get any trickier than that. That's all it was. What else are we going after? Boxville. Right. Let me get there. There we go. All right, let's get the code book out.
Okay.
And we're going to be dancing around 314, 16, 314, 28. You there?
Yes, sir.
All right, cool. All right, so these are the tables. When you re-watch this, highlight your tables. These tables right in here. One is
Okay.
actually 16 is the 16A is your box sizes. They'll give you like a 4 square deep or 4 square shallow, octagonal, whatever. That will give you your measurements on this. And this one right here, 314 16B.
Mhm.
That gives you your wire size, and this is very important, and you'll see this here in a little bit how important this is on depending on 14 gauge or 12 gauge or 10 gauge. It'll be a multiplier for you to figure out your cubic inches on your boxes.
I do remember having the question talking about how many number 12s can fit in a 1-inch FMC.
Okay, all right, that's this one's a little bit different. This was
Okay.
box sizes. Your FMC is in the back. We'll get to that here in a second. All right. So we'll highlight, like I said, you'll highlight those. And what you got to remember is inside a box, your conductor fill is counted once. So your wire size is counted once. So then your clamp fill, and this is a little Romex clamp that we have there. Let me open this up so you can see a little bit better. This little clamp right here, that's counted as once. And what it is, it's 1 times the largest conductor within the box. So you're asking, well, what the hell is that? Let's go back to 314 16B, that table right there. And on the left-hand side, it says size of conductor, and it starts with 18, 16, blah, blah, blah. On the very right-hand side, you'll never use centimeters cubed. You'll always use
inches.
inches. So what you'll use is you'll use 14, 12, and 10 AUG. And on the right-hand side there, you'll notice that 14 is 2.00. And then 12 is 2.25, and 10 is 2.5.
So it goes up by 20.
What's that?
It goes up by 25%.
Or yes. But what you'll need is right here on the screen, your conductor field. Let's say we're using 14 just for simplicity purposes. You've got a conductor field counted once as per this table. So you got a 2 now, and we'll just work on that. That's 2. And then you've got a clamp fill counted once based on the largest conductor presence, and we'll say it's 14. So you got to count your conductor, and then you got to put another 2 down for your clamp fill if you had a clamp in there. Bear with me.
So it'll be 2 times.
What's up?
2 times 2.
Right, so far. And now in Article 14B 14.16B3, they talk about luminaire studs and hickeys. And that's what a luminaire stud and a hickey is right there. Just remember, it's just taking up volume in your box.
Mm-hmm.
So you count that once based off the largest conductor. So if we had that in there, we would count a 2 because we're running number 14.
Mm-hmm.
And then on your device, they in the code, they talk about a yoke, and it's 1 yoke. You count that twice. So on a 14 gauge, that would be counted as 4. As a 4. And what that is, it's the volume that's being used up in your box. So if you had an 18 cubic inch box and you had 114 in there, that'd be 2. And you had a clamp on it, that'd be 4. And you had a hickey in there, and that'd be 6. And then you had a receptacle, and I'm just throwing shit in this box. Of course, it's not all going to really be there, but
Yes, sir.
But if you had a receptacle in there, that would be another 4, which would be 10 total. 10 with all the devices and clamps and conductor that's in there. That'd be 10. And you would subtract that from 18 because you had an 18 cubic inch box, and you still had 8 cubic inches to deal with. So when you're pulling wire or you've got a smaller box, you need to be able to do your box fill, just because of the heat that gets trapped in there, and it starts messing with the amperage that's able to go through that wire.
The ambient temperature.
Exactly.
Okay.
Exactly. So that's why they do that. So we got to go in there, and what I do is for B1, I'd highlight conductor fill and put a 1 by it in your book. And then B2, clamp fill, put a 1 by it. And then support fittings, put a 1 by it. And then device equipment, put a 2 by it. And that'll be a quick reference on how to add up all the stuff that's in there.
Mm-hmm.
And remember, it's a multiplier, not just a 2 or a 1. It's a multiplier.
Okay.
Let's see where we at. So what you do there, you just add all that up. Depending on the question, it's gonna give you something in there. And it may give you, like, they change it all the time. It's usually number 12, so it's going to be a 2.25.
Mm-hmm.
And then they're gonna throw a receptacle in there, or a switch, or a snap switch in the box. And then also, why not get this to also we got to put a ground in there. So your grounding conductor counts as 1. So if they tell you there's a grounding conductor in there, you need to be able to, you got to, use that multiplier, multiply it times 1 and add that in. So if we were using 14, it'd be another 2, which would make that box fill into 12 instead of 10. So you'd only have 6 cubic inches left instead of 8. So go in there and highlight your book here and put a 1 by it.
3, 14, 65.
I'm just telling you this now, assuming you're going to go back and rewatch this video, then you can go back in there and highlight it up. So you've got your wire. You've got a clamp fill if present. You've got support fittings if present. Your devices, and then your ground. I'm just telling you, I'm just going to touch on this real quick on this ground. It changes in 2020. So just be aware of that. I won't get into it, but it does change this rule a little bit in 2020.
Okay.
But your question is going to be, it's going to give you like 2 or 3 or 5 or 6 or 7 number 12s. Now it could give you some number 12s and number 14s, but you know how to go in there and differentiate the 2.0 versus the 2.25, just depending on the size of the wire. And then if you have a 12 and a 14, remember, going through the math, you will use 2.25 for the rest through all of this right here, because it's based on the largest conductor present. So just remember to use that. I don't think they add 2 different sizes on you guys on your Journeyman's test. So just be aware of that.
Okay. Always use the higher.
Always use the biggest
size.
one. Always. And it's right there. And you may want to highlight that in your code book, largest conductor present, just to give you a little reminder on that. But that's how you do box fill. Your little nut, like holding your EMT connector or anything, your little lock nut that you screw in the box, that does not count on your deductions up here.
Okay.
So
it's just like the clamps or like hickeys and stuff like that.
Yep, exactly. And they're going to use luminaire studs, and they're going to use the word hickey if you see it, because it's just going to throw people off, because people don't know what that stuff is. We don't use that terminology. So just be ready for that.
Okay.
Okay, so that's how we do box fill. Can you see this whole question, or are we in the way?
No, it's fine. What is
Okay.
the cubic inch?
Now, what they're trying to do right here is they're throwing you off with insulation. Insulation means nothing when you're finding box fill. It's the only thing that you're worried about is you're worried about that right there.
The wire size.
Right. So what is the cubic inch volume required per conductor for number 12? And all you do is you go back to 31416B, and it's 2.25. Remember, it's that multiplier.
That's the question. That's the answer.
That's the answer.
2.2.
Yeah, okay. 2.25.
So
then they'll
throw
start throwing distance on you and insulation and blah, blah, blah. And that's not what that has nothing to do. That's just fluff. Or junction boxes shall have a. All right. So let's go to bigger junction boxes. Something with 4 AUG or better. So instead of a little 4 square box, we've got a 24 by 24 inch junction box that's coming through, and we've got some conduits coming in, and I don't know, you're pulling, let's just say you're pulling 4 AUG. What you do is if you have a box and you're going from side to side, so you're doing a straight pull through that box, your multiplier is 8 on the largest conduit going into that side of that box.
Okay.
Now, if you have that same box, and instead of going from the right side to the left side, we come in from the right side and we go down. We use it as an angle. We multiply it times 6 of the largest conduit. So if you had let me see if I got this. Oh, I know. So if you had a number, if you had a 2-inch conduit coming in the side of this junction box, and it went straight across and went out the other side with a 2-inch conduit, you would have to take that 2-inch conduit and multiply it times 8, because straight 8 is your multiplier is 8. So you take your 2-inch conduit, multiply it times 8, which is 16. So the minimum size of that side of that box would be 16 inches. Now, they usually don't sell a 16-inch box. You'd have to round it up to a 24. And also with the other side, it'd be a 16 and a 16.
If
Does
you're
that make
going in-
sense?
Yes, sir.
Okay.
Straight through is 8. Multiply the largest conduit, and any turned corners would be 6. Largest
Exactly.
conduit.
Exactly. Same thing. So if say we had say if we had the same thing, a 2-inch coming in the side and then a 2-inch coming up the bottom, it's a diagonal. So that'd be a 6. So that'd be a 12-inch box versus a 12 by 12 box is what you're trying to figure out, is what you're finding. And they do have 12 by 12s. So as long as you're doing an angle, you're getting that you're using that multiplier of 6.
Okay.
But straight is 8, and then angle is 6. And that'll get you your box size. It doesn't matter about your wire or any of that. Now, if we had, let's go back to our straight 8, our 2-inch on the right side, 2-inch on the left side, and then we had 2 more 1-inchers coming in the right side and leaving on the left side. You just add it one time. So it'd be 2 times 8, your largest conduit, and then you would add the 2 more, one for each 1-inch conduit. So you'd have an 18-inch minimum size on that box, because you'd have 2 times 8, 16, and then you have those 2 other 1 inches coming in, and so you would just add those up.
Add them 1 inch. So if it was, of course, you're going to go with the biggest.
Correct.
So that really
you have to go with the biggest to do your multiplier. Just kind of like our conductor fill, our conductor from previous, how we had to take the biggest conductor and then use our multiplier from there. Same thing with that. You take the biggest conduit, multiply it times either 8 or 6, depending on your application, and then you add the other conduits that are coming in the side, the top, or the bottom. So they could be. Go ahead.
If you had like a 2-inch and then you had an 1.25 inches and an 1.5 inches, you just count for 1, right?
No, you go 2-inch times, say we're going straight, 8. 2-inch times 8 is 16, and then you add an 1.25 inches, you add 1.25, and then you add 1.5. You don't add
so
1.
Whatever size pipe is.
Well, correct.
Okay.
You don't multiply it, you just add that pipe to it.
Okay.
And then that will get you your box fill. And remember, it's on wire 4 AUG or better. So number 4 or better or bigger is when you use that math, because if you go back to what was that, 31416b or whatever, that showed us the number 12 was 2.25 and number 14 was 2.2. Well, if you go all the way to the bottom, I think it stops at number 6.
Yeah, number 6 at 5.0.
There you go. And now number 4 is where you pick up the straight 8 or the angle is 6. That's where you start using that multiplier.
Okay.
So you've got your smaller stuff, then anything over number 6 4 or bigger, you've got your bigger stuff with your multiplier. Took care of that. All right, let's go over one more thing. Let's go over your how many 15 amp breakers are required. I've got a question here that I've practiced with, and it's pretty much what you brought up. It says, how many 15 amp branch circuits are required for lighting of a dwelling unit that's 3 levels with the outside dimensions of 40 feet by 23 feet? So you just do your square footage on that, which comes out to 40 times 23 times 3 is 2760, and then you multiply that times your 3 VA because you're on a single family dwelling.
Eight 8,280.
Right. And then now this is where you gotta kind of think about this. You're at a 15 amp circuit, so that's 120 volts. It's not 220, it's 120 volts. So
you divide.
Exactly.
So it'd be 69 receptacles.
No, 69 amps.
Oh, so that's what the amperage is.
Exactly. And you have 15 amp receptacles. So you need to divide again. You need to divide
By
69 times, divided by 15.
4.6.
Exactly. Which rounds up to 5.
Okay. That makes sense now.
Cool.
Yeah, that makes a lot more sense now with that.
So you just take your square footage, get it all figured out, multiply it times 3 VA, which is required for a single family dwelling per square foot. Then divide that by 120 volts. And then that gives you your amperage, and you divide that by 15. And then that'll give you how many circuits, how many 15 amp circuits you need. Now, if they were asking for 20 amp circuits, you just divide it by 20 instead of 15. But since they're asking for lighting loads, those are 15 amp circuits. So that's how you do that one.
Okay. I don't really remember if there was a question too. There's something about receptacles and I think it was a heater, but you always go with the bigger size on the nameplate. So I think that's what I did on that one. Can't remember the question.
Okay.
Next time I remember it.
Is that on a single? Are you figuring? What were you trying to? What were you trying
honestly, I can't remember. I just remember something about window units and a heater. So I just went with the higher nameplate
so
rating.
you were figuring out the load of a single family dwelling.
Yeah, I believe so.
Okay. Have you looked at the in Annex D? Have you been back there
Yeah,
yet?
I have it highlighted, but
Okay.
the I don't know if I got the right answers.
Okay, but you've been back there and you've kind of worked all those examples and stuff.
Yes, sir.
Okay, familiarize yourself with those examples because those will help you if you forget during your test a step or something. You can go back there and look at this and it tells you exactly what to do on figuring out multifamily, single family dwelling, all that stuff.
Okay.
With or without, optional method. If you look at example D5A, it's a multifamily dwelling service at 208 120 Bolt.
Mm-hmm.
And you go through there and you start reading it and it says equivalent of three-phase load on your minimum size feeders required for service equipment to meter banks for 20 dwelling units with 10 ranges.
Mm-hmm.
And you see the equivalent three-phase load is 54,500 VA.
Yes, sir.
That right there was a test question for me. So I
That
didn't,
208.
well, those numbers, those everything
Mm-hmm.
were right there. So if all I've got highlighted equivalent three-phase load as the demand load. And so I knew where that was. So I didn't have to figure out all that stuff. I knew where it was. And boom, there's the right answer. And same thing with the next one down. The minimum size main feeders, um, less house load for 10 dwelling units with 20 ranges. We were trying to find the equivalent of the three-phase load, and there it
Mm-hmm.
was already for us right there for in the examples. So what I'm getting at is kind of go through these examples and kind of know what's in there because some of
Because
those
the
questions that are on those tests come directly out of that. They know that
yeah,
directly. So you don't even have to do the math. I mean, there again, that saved me probably about 4 or 5 minutes working that equation out, all those equations, and making up time. So
yes.
spend some time back there and
Check.
check it out and know it.
Okay.
Oops. I'm about to lose you. Cool. Well, we went over everything. It was fast and furious, but like I said, we can get you this video over here, and you can review it and go
Okay.
from there.
Yeah, that'll work. I'll go off that and do some practice and
I know we went real fast, but I also was doing that real fast because I knew you could go back and you could self-pace yourself um on your video and stuff. So
yeah, it's easier to go back.
yeah, on your own and stuff. So
Okay.
cool, man. Um, study away. What do you got next?
Yes, sir.
Not this week, but next week you're gonna test or no?
Yeah. Yeah, I'll call tomorrow because I don't know if they're open today since it's kind of the day after a holiday. So
Right.
tomorrow I'll try to schedule for next week sometime.
You can get online and schedule.
I've tried online, but it's just I don't know. It's
Okay,
weird
cool.
because it only comes up as the practical. It doesn't show the written or theory.
Oh, okay. Okay.
So I
Cool
usually
deal.
just call so they can do it for me.
Yeah. Yeah. That'll be awesome. Cool, man. It,
But yeah, I'll do it more and see how it goes now.
yep. Yeah, you got introduced to some more stuff and you'll be ready. I mean, with the
Yes, sir.
70 and with what you've got introduced last week or so, you should do well.
Okay. Well,
You should.
hopefully I'm gonna be studying and going over.
Nah,
I'll
you'll do good. You'll do well. You'll do well. So yeah, we'll
pass that one.
get that written taken care of, and then we can work on theory. So
Yeah.
cool. Well, this will be it. Have a good day, man. If
You
you need
too.
anything else, just shoot me an email and we'll go from there.
Okay.
But
Yeah. I'll schedule time once I get everything going and see how I do, and
okay,
hopefully I'll start on the theory.
excellent. Yeah, just let me know how you did, good or bad or whatever. Um, you're already doing this, but when you step out of that testing center before you do anything, just have you a notepad and a piece of paper right there and just start writing stuff down that you're not too sure about or you had some questions about. Even before
Mhm.
you put that key in the ignition and whatnot, just write it down real quick. And then because it's 5 minutes from you leaving, you'll forget, you'll start, was it this or was it that? Just write it down and then you can go from there.
Yeah.
So
Okay. Well,
cool, man.
I appreciate it.
You bet. Like I said, just give me an email, shoot me an email if you have any other questions, see what we can do for you, and we'll go from there.
Okay, that'll work.
All right. Have a good day.
You too. Talk to you
All right.
later.
Later.